It's another learning day, everyone. Again, this is your teacher, Marlene Nuno, and I'm going to discuss about the triangle bisector theorems. Let us start. So let us study about the triangle bisector theorem. It is described that the bisector of an angle of a triangle separates the opposite side into two segments whose lengths are proportional to the lengths of the other two sides of the given triangle. So to easily illustrate this, let us have our figure of triangle X, Y, and Z. Now let us draw YW. And this YW bisects angle Y. So we can say that angle XYW and ZYW are congruent angles. Then we can have the proportionality between XW to WZ, and that is equal to YX to YZ, or the vice versa, WZ to XW, and that is equal to YZ to YX. Now to further understand about this triangle bisector theorem, let us have our proof. So we have our triangle XYZ, then YW bisects angle XYZ. And we have to prove the proportionality on XW is to WZ, and that is equal to YX to YZ. From the original figure, let us extend YZ to other side, and then let us also draw XV. So in the figure, we have angles 1, 2, 3, and 4. And observe the symbols. XV is parallel to WY. So let us use this figure and let us have our statements and reasons. For statement number 1, our triangle XYZ is our given, that is YW bisects angle XYZ. Then, we can say that angle 1 is congruent to angle 2. This is by definition of angle bisector as stated in statement 1. Then, from the illustration, we have drawn the auxiliary line through X that is parallel to WY. Then extend line ZY. That is by construction of parallel lines. Then angle 2 is congruent to angle 3. And these are lines cut by the transversal, and they are congruent. Then angle 1 is congruent to angle 4. So in the figure, we will observe that they are alternate interior angles, and also they are congruent. Now we can say that angle 3 is congruent to angle 4. So using our statements, numbers 2, 4, and 5, by substitution, we can see the congruency between the two angles. Now XW is to WZ is equal to VY is to YZ. That is our basic proportionality theorem application. Then, XY is congruent to VY. If two angles are congruent, then the sides opposite them are also congruent. This is from the definition of our isosceles triangle. Then XW is to WC is equal to XY to YZ as what we have to be proved. And that is by substitution using statements number 7 and 8. Now let us have its application. So given is HD that bisects angle AHE. So look at the figure. Now we have to complete the following table using the triangle bisector theorem. So starting with set 1, let us indicate our given in the figure. So the length of AH is 18 units. HE is the unknown, the same with AD, and then DE measures 25 units, and the whole AE measures 40 units. Now let us have our solution to solve for HE and AD. And let us start with AD. So by segment addition postulate, we can say that AD plus DE is equal to AE. Then by substitution, we have AD as the unknown plus the length of DE, which is 25, is equal to the length of AE, which is 40. And of course, by addition property of equality, by adding both sides by negative 25, so that we will arrive at AD is equal to 15 units. On the other hand, let us solve for HE. Now for triangle bisector theorem application, we can now say that the side AH is proportional to AD, and that is equal to HE is to DE. Then by substitution, the length of AH is 18 while AD is 15. Then HE is the unknown and 25 for DE. Then by cross multiplication, we have 15HE is equal to 18 times 25. And then solving for HE, we will get HE is 30. You can check for the answer. Now let us have more application by solving our set 2. So in the figure, the length of AH is 8 units, while HE is y minus 2. Then AD is 9 halves, DE is y over 2, and AE is also unknown. So let us solve this. Now before solving for HE and DE, we need to solve first for the value of y. So let us start in our triangle bisector theorem by indicating our proportional parts that we have AH is to AD is equal to HE is to DE. Then by substituting the values, we have AH is equal to 8, AD is 9 halves, HE is y minus 2, and DE is y over 2. Then by cross multiplication, we have 8 times y over 2 is equal to 9 halves times y minus 2. Then to simplify the fraction, let us multiply both sides by 2 so that it is simplified to 8 times the y is equal to 9 times the quantity of y minus 2. Then let us distribute 9 in the quantity y minus 2 so that we have 8y is equal to 9y minus 18. Then by addition property of equality, and then simplifying the result, the value of y is 18. Now, since the value of y is 18, we can solve now for HE. Then by substitution, using HE is equal to y minus 2. So since y is 18, 18 minus 2 by subtraction is 16. Now for the length of DE, by substitution, we have DE is equal to y over 2 and y is 18, so 18 over 2. Therefore, DE is equal to 9. Well, that's all for today's lesson. It's time for me to check how well do you know. Try to answer this. In triangle bisector theorems, we will observe some important concepts. So which of the following is not included? Is it A, bisected angles, B, the proportional angles, C, the congruent angles, or D, proportional sides? Well, that's all I can share. If you have some questions or clarifications, just let me know by writing your comment below. And please keep on watching my YouTube channel, Teacher Marlene Nuno, and do subscribe and hit the notification bell for the updates of my videos. Thank you for watching. God bless everyone.